Have you ever stopped to think about how the internet actually works? I mean, with billions of devices connected all at once, how does an email you send from London find its way to your friend's laptop in Tokyo without just getting lost? How does your phone know exactly which server to ask for that cat video you're about to watch? It all comes down to a really elegant system of digital addresses. So here's what we're going to cover. First, we'll start with a super simple analogy to get us going. Then we'll get into what an IP address actually is. I'll even show you how to find your own. We'll talk about the crucial difference between public and private networks. And then we'll put it all together to see how data finds its way across the globe. Okay, so let's start with the big idea. To really get a handle on this, just imagine the entire internet as one giant worldwide postal service. Seriously, this one analogy is the key to understanding pretty much everything else. The real challenge here is just the insane scale of it all. This isn't like a small-town post office. We're talking about a network that spans the entire planet. So how do you make sure your message finds its one single destination out of billions of possibilities and gets there in like a fraction of a second? And this is the solution. Every single device, your phone, your laptop, your smart fridge, you name it, gets a unique identifier. It's just like how your house has a mailing address. We call this an IP, or Internet Protocol Address. Without it, you couldn't even shop online because the store's server would have absolutely no idea where to send the confirmation page. All right, let's move on and actually look at what one of these addresses looks like. It's time to pop the hood and break down that string of numbers you've probably seen a million times. The most common kind you'll bump into is an IPv4 address. It's always made of 4 numbers separated by dots. Each of these numbers, which has the fancy name octet, can be any value from 0 all the way up to 255. And that's it. That's the whole recipe. So if you've got a 32-bit number, how many unique addresses can you make? Well, the math is 2 to the power of 32, which gives us about 4 billion unique addresses. Now, back when the internet was first designed, that seemed like an impossibly huge number. But as we're about to see, it's caused a few problems. Now, hold on. Not every one of those 4 billion numbers can be assigned to your laptop. A couple of them are reserved for special tasks. The first address in a range, the one ending in .0, that usually identifies the network itself, kind of like the name of the street. And the very last one, .255, that's the broadcast address. Sending a message there is like shouting through a megaphone to every single device on that network at the same time. Okay, enough with the theory for a minute. Let's make this real. In this next part, I'm going to show you exactly how to find the digital address for whatever device you're watching this on right now. You know, this is actually way easier than it sounds. Just open up your command line tool. On Windows, that's the command prompt. On a Mac or a Linux machine, it's called the terminal. So for Windows, just type ipconfig and hit enter. If you're on a Mac or Linux, you can use ifconfig or my favorite, the shorter IPS. Go ahead, you can even pause and give it a try. Okay, you're going to see a bunch of text that might look a little confusing at first, but don't worry about it. Just scan through and look for a line that looks something like this. You'll see the word init, followed by your address, something called a net mask, and that broadcast address we talked about. All right, let's break this down. The init address, that's your device's unique ID on your local network. The net mask basically tells your computer which part of that address is the street name and which part is the house number. A really common one like 255.255.255.0, which you can also just write as /24, means those first 3 numbers identify the network. And hey, look at that. There's our broadcast address again. Now, that IP address you just found, it's almost certainly what we call a private address. And this brings us to a really important concept in how the internet is put together. See, not all IP addresses are created equal. Here is the absolute best way to think about this. A public IP is like your home's postal address. It's totally unique in the entire world. But a private IP, that's like your apartment number. Apartment 101 can exist in your building and in the building right next door, and it doesn't cause any confusion because that number is only meaningful inside that specific building. And these private address ranges are actually standardized. If you ever see an IP that starts with 10 dot or 17.2.16 dot or the super common 192.168, you can bet it's a private address. That CIDR column is just a shorthand for how big the network is. This is the pool of addresses your home router is using to talk to your phone, your laptop, and everything else. So we've got addresses. We know there are public ones and private ones. So let's get to our final section and see how a little piece of data, a packet, actually uses these addresses to get where it's going.
And this is where our postal analogy comes full circle. Routers are the post offices of the internet. When your data packet gets to a router, the router takes one look at the destination IP address, the public global one, and sends it along to the next router that's just a little bit closer to where it needs to go. This happens again and again and again, hopping between routers all across the world until it finally makes it to its destination.
And all that leaves us with one last kind of fascinating question. We've established that there are only about 4 billion IPv4 addresses, but there are well over 15 billion devices connected to the internet today. So how does that work? How can we possibly have more devices online than we have addresses? Well, the answer involves a very clever trick called NAT and a whole new system called IPv6. But that's a story for our next explainer.